This is a practice exercise from page 174 in the textbook. We're looking at using enthalpy, or the amount of heat absorbed or released during a chemical reaction, in order to perform stoichiometric calculations. So what we're going to be doing here is using this delta H number in a way very similar to what we would do when we use mole ratios. So if we read this chemical reaction, it tells us that for every 2 moles of hydrogen peroxide that decompose, 2 moles of liquid water and 1 mole of oxygen are formed, along with 196 kilojoules of heat. We know that since this has a negative sign, this is an exothermic reaction, which means that heat is released. So we can think of heat as a product in this reaction because we are releasing heat. Conversely, if this has a positive sign of delta H, it would be an endothermic reaction, and we would say that the heat was being absorbed. So, if we look at the information they give us in this problem, we are starting with grams of hydrogen peroxide. Since we know that we are eventually going to use information from the balanced chemical reaction, that means we need to change grams into moles. In order to do that, we're going to need to know the molecular weight of the hydrogen peroxide, and that is going to be equal to 34 grams per mole. So now we're ready to start our stoichiometric calculations. We're going to start with our 5.00 grams of H2O2. We know that 1 mole is 34 grams. And we also know that for every 2 moles of H2O2 that are decomposed, and again I know it's 2 based on that balanced reaction, for every 2 moles of H2O2 that decompose, we release 196 kilojoules of heat. So our grams cancel, our moles cancel, and we're left in units of kilojoules. So if you put that into your calculator, you should get negative 14.4 kilojoules when you round that to 3 significant figures. And again, it's important to think about how these questions are asked. Since it's asking us how much heat is released, we can either write it with a negative sign, because the negative sign implies that this is exothermic and heat is being released, or we could just say that 14.4 kilojoules are released. The word released kind of takes the place of the negative sign, because if heat is released, obviously we have an exothermic reaction. So this is how you do stoichiometric calculations. You can just use that enthalpy value, very similar to how you would calculate with moles of any other product or reactant. It's just part of that entire chemical equation.